All right, everyone, let's continue on with the program. In this next talk, we're going to explore the journey to Hedera EVM Equivalence. So our next speaker is going to get into the Hedera's adoption of the Besu EVM. He's going to highlight the JSON-RPC relay, also how we have enabled the use of HTS tokens with ERC standards. And so to cover all of that and more, I want to welcome to the stage Director of Software Engineering at Hashgraph, Nana Essilfie-Conduah. Welcome, Nana.
Hello, good morning. Welcome to HederaCon. I hope you guys are enjoying yourself so far. As Ed mentioned, I have the pleasure of talking about the road to Hedera's EVM equivalence. My name is Nana Essilfie-Conduah. Like Ed mentioned, I'm a Director of Software Engineering at Hashgraph. I've had the pleasure of growing up on a few continents and working in a couple of different fields. And one thing that has continued to go through is just that technology can be complex. It's very useful, but at the end of the day, it needs to just work. Jasper and Richard mentioned earlier, it needs to be simple. So we have that sort of responsibility. We all as builders and people talking about blockchain, its benefits and everything, we just need to make it simple. We need to make it work, and that's the way we preserve the value. So a couple of you will be familiar with some of these things, but let me go over them. Hedera is an open source, proof of stake, enterprise-grade scalable blockchain, all right? We support 10,000 transactions per second, and that's mind-boggling, all right? Jasper and Richard were talking about this before, but don't just take our word for it. I would love for you to test this out. We've seen other companies try and do this, and I'm not saying this out of mathematical, suspicion or something. These are tests that we run every single month, every single time we upgrade the network, right? And we're actually doing a bit above this, but these numbers are thresholded. So 10,000 transactions per second, go ahead and try it out. We also pride ourselves in being cheap in terms of our transaction fees. And so on average, our transactions are about 1/3 of a cent. This means that I could take anybody in this room, anybody online right now, and if I were sending you any value of HBAR, I could send that to you for a cost of 1/3 of a cent. And on the next part would be with a finality of 3 to 7 seconds. Now, I've put a range there, and I want to talk about that range. The first part of that, 3 seconds, is consensus, right? So this is saying that your transaction, after you submitted it, was included in consensus. So within 3 seconds of submitting that, you can check for certain that your transaction was included in the blockchain. And the 7 seconds part is the outcome of your transaction. As Richard noted, all right, consensus and execution. And so the 7-second part is that execution went through and the information from the transaction and the output is available to you. To me, this is mind-boggling because I remember back in 2017, where my journey kind of started off was I was building out dApps and smart contracts. And I remember doing demos for customers and trying to show them that blockchain is the future. This is how it's going to happen, right? And you have all this information, all these cool things, and then you press click, and then you see the wheel just spinning. It's spinning. For seconds, it's spinning. A minute passes, and it's still spinning, and you're trying to convince people. And so if that version of me had been told that I could point at Hedera and have all of that happen within 3 to 7 seconds, that would be a game changer for me. For those of you that are interested in the smart contract side, we support 15 million gas per second, right? Compare that to a couple of other chains. Again, like Richard and others had mentioned, they do some really cool stuff. We do things a little bit differently. So this concept that a smart contract developer, any dApp that you're working with that interacts with the EVM can do 15 million gas per second. Our block times are every 2 seconds. That just, that opens up things like gaming and other sort of like high throughput scenarios that you can do on the blockchain. We also pride ourselves in being very good on the sustainability side. And we like to say these things, but we also like to be on the receiving end of independent studies. And so we're fortunate that the University College of London did an independent study. They looked at a couple of different blockchains, and they even included the Visa network, right? And you see that little green blob up there? That's us. That's us being really good to our ecosystem, being good to on the sustainability side, and that's in comparison to all these other ones. And so Hedera is the greenest blockchain, and just for numbers, we're about 1,000 times less expensive than a Visa transaction. So when you go swipe, or if you swipe this morning and got some coffee, a Hedera transaction is 1,000 times cheaper than the energy expense that is put on the world and the ecosystem there. So I kind of like this slide, and Richard spoke to this a little bit more, but I've seen a couple of articles over the years on, is Hedera a blockchain? And sometimes it's yes, sometimes it's no. When it's no, it does this really interesting comparison where it talks about Hedera, but it compares it to the consensus model of something else, right? I want to say for a fact, Hedera is a blockchain. Richard spoke about this before. One of the nice ways I like to think about it is that a blockchain doesn't talk about its consensus mechanism. A blockchain doesn't talk about the way in which the transactions are really stored, right? Those, to me, are implementation details that allow you to move forward in time, to move with technology, and to get better. But the idea of a blockchain is really just a distributed ledger that orders transactions, fairly, and it allows them to be linked and independently verifiable, right? Tamper-proof. Jasper mentioned this before. And so you would have seen that some traditional blockchains all agree on this. A block is a collection of transactions. But you'll see that as the blockchain is sort of like, going up through that middle, there are points in time, depending on the block times, where there's a fork, there's a spin-off, and part of the network thinks that this is the direction in which the blockchain is moving. But then a second later, it turns out that, no, that wasn't the right one. We were actually on this other path. And so think about your application. That goes back to the example that I mentioned before. You have spent time. You have customers. You have users that are like, sweating, waiting for that transaction to go through, and then they can do something, only to find out that they thought it was included, but it wasn't, right? And that like I said, different choices for traditional blockchains. They have different implementation details. And so sometimes the blocks that they recommend aren't actually included in the consensus and the final blockchain, as it were. Whereas we have Hedera on that other side where, Richard mentioned this, it's a nice, linear progression in time. And one of the ways we get that is that our transactions, we group them first into events, right? And that's what's gossiped out between each other. And that's the thing that comes to consensus within that 3 seconds that I spoke of. So you are assured, regardless of the outcome of your transaction, that is included in the blockchain, right? And then these events are what's ordered. And so we don't fork. You're always moving forward. You never have to worry about uncle branches or anything like that. So anytime that comes up again, you can say with certainty that Hedera is a blockchain, right? So let's get into the EVM side. Again, I don't want to presume everybody's knowledge of this. So at its simplicity, an EVM, the Ethereum Virtual Machine, is a computational engine. You also hear it called a state machine. The reason being that it can take from a given state a transaction coming in, execute that transaction according to some predefined rules, and take you from that starting state to another state. And then it's really up to the network to sort of persist and make that go forward. But at its simplicity, that is it, right? And one of the things I like about that is that it's network agnostic, it's chain agnostic. It really means that the EVM is the computational side or the operational side, and it should be able to move around. It doesn't need to get stuck to Ethereum. And that's essentially what Hedera has done, right? We've taken an EVM client, and I'll talk about this a bit more, but we use it as an executional client. That means when your smart contract transactions are coming in, we are using an EVM, and we are applying that, but it also allows us to sort of continue to move with our advancements in state and performance advancements that we had said before, and we don't need to get stuck to that. So, as I had mentioned, that's the nice view, right? The EVM should be able to move around, but when you're building applications, you guys have all probably done it before, you make some decisions. You don't have all the information in time. And so unfortunately, what happened is that some implementations of Ethereum are stuck inside the EVM. Some things within the EVM that are great should be customizable, but are not, right? And so some of the challenges, for example, is that there are hard forks of the EVM, and these are exact forks, right? So what that means is that sometimes a feature that worked in 2016, 2017, 2018 gets broken in 2022, and it's no longer sustainable, right? On Hedera, we pride ourselves in not forking, which means that if you have functionality today, you can rely on that going forward. And so that's one of the things that kind of tripped us up that we had to consider. Another one, you heard about the Ethereum JSON-RPC API. It's very focused on what the EVM does, which means that if you do things outside of the EVM, let's say native operations, it has no way to express that. So that was another challenge. Gas-based pricing, again, a really good idea. The EVM thinks about what's the work I'm doing. When you bring in your transaction, what hard work do I need to do? And then I can price it in this thing called gas. But then what happens when the work is outside of the EVM? It makes it hard to bring that concept of how much does this transaction cost? What effect does it have on the network state? How does it, affect progression over time as state begins to get bigger, right? The EVM also overfits on the 256-bit elliptic curve. This is actually something that Vitalik spoke about. He said if he had the choice to go back, he might do it on a 32-bit or a 64-bit, and then have some additional considerations for like really complex math. Some more challenges. The EVM made a choice to be very based on ECDSA-based cryptography, right? And so accounts are linked to ECDSA type public keys, and I'll talk a bit about that. But what happens when you're on a network where that's not the only type of account that you can do? What happens when it's more, right? What happens when you think about quantum resistance in the future and scaling, right? Their type of hashing, the KEKAC 256, again, that's something that's like heavily embedded, but maybe should have been a configuration choice. And then finally, all the costs are settled in Ether, which is, 18 decimal points on that. Again, a choice, a good reason, but again, should have been configurable, because if you go to another network that decided to use a different number of decimal points, then you have this conflict. So we had these, I'd say, areas of interest, considerations that we needed to go, and it brought up some interesting questions. How do you represent native transactions that don't go through the EVM? How do you account for different types of accounts that are using different cryptography? How do you do all of this and still honor the implementation and expectations of the EVM, especially when it bleeds into the dApps and other things like that, or the smart contracts? And so the question came up, should Hedera be EVM compatible, or should it be EVM equivalent? And I wonder which one you guys think we chose. Any takes? I'll spoil it for you. We went for equivalence, right? And we had a choice there. We could have gone for compatibility. This is the discussion in the ecosystem, right? Compatibility would mean that we look like we support the EVM, right? Behind the scenes, we're doing lots of different things, and then at the end of the day, we make it look like that. But then we have all of these challenges. Equivalence says that we don't want you to care about the details. We want you to be able to come from another EVM chain to come to us and have the same expectations, and we want to be able to grow. We want to be able to give you the best experience there. And so you might ask, why did we do the harder thing? The simple answer is our users were asking for it, right? And we need to be attentive to what our users are asking for. In terms of the ecosystem, we had developers, we had partners that we would have discussions with, and we would tell them that we're faster, we're cheaper, and they'd say, that's all great, we want to use you, but we've like heavily entrenched ourselves into the EVM. Like literally, our companies are built around this ecosystem, and so integrating with you might be difficult. That was one reason, right? But also, adopting the EVM allowed us to speak the same type of language with everybody else that might have been there before Hedera came out. This would lower the barrier to entry of people coming to Hedera. It's always great when you come into a new field and you're like, you can take existing knowledge that you had before. You can say, hey, I've become an expert at this thing for the last 5 to 6 years. I can bring my insights and I can keep running on this thing that is better, but I don't need to start afresh. Some people are happy to start afresh, but not everybody, right? This also allows us on Hedera's side to increase the reach of people. Richard had mentioned open source, and that's a big thing for us. Open source means we want to make it for everybody to be able to contribute, right? And so now we're not just thinking of Hedera developers only, we're thinking about the Web3 collective overall, and we believe that they can contribute. And our ecosystem now begins to grow because dApps and other solutions that have existed on EVM chains can now say that, hey, I'm thinking of a multi-chain approach. I can add Hedera to that list now because of this equivalence. So we decided to go for equivalence, and I like this image because it kind of shows what the pursuit of equivalence looks like. You have this valley, you have these hills, you can kind of see the end, and you think maybe it's a trek that you could make, but you have to admit that like it's not going to be easy. You want to get to the top of those hills, but you're not sure what's on the other side, but you are committed to that process. And so what we decided to do was focus on 3 core areas: security, node features, and experience. So security is one of those things where if you do it right, you should think about it at the beginning. We've all been in those situations where we focused on the feature set, we focused on the functionality, we've read articles where really great things were happening and then something bad happens. And it was always, oh, I was gonna get to the security side of this. And so we tried to do this as much as possible at the beginning. So let me just go over some quick things. So usually what happens with a smart contract execution, that green person is me or you that clicks on their wallet and says, I want to execute some smart code logic, right? Or smart contract logic. So that's that contract A. It has some information about who the originator was, who the sender is. Sometimes these may not be the same things. Who the recipient is, the contract that I'm calling, is value being sent, and what is the actual address of that contract. Sometimes what you have is that contract A calls contract B, does the same thing. The EVM needs to know who started this whole thing off, who was the sender, who's the recipient, value, etc. Right? And what's important there is that the EVM security model says that an account can only modify its own properties. So if these things don't match up, if say the sender is not the same as the address in which is being modified, the EVM will not allow that. And that's a good thing, right? You don't want somebody else modifying your balance, but you should be able to modify your own balance, right? What's interesting is that the EVM also allows for this scenario at the bottom where contract A could call contract B, but tell contract B to execute itself in contract's A state. Right? And so the values change here, right? Contract B's logic now can act on contract A's state, right? And you use this for different scenarios, sometimes upgradability, and usually it gives you more options. But when not applied well, somebody can abuse that and have you accidentally or unknowingly call contract B, and then they can do some nefarious stuff on your end. But when you compare this to Hedera's model, we decided to go on the different side, right? We weren't necessarily looking at contract A, contract B. We were looking at the top-level transaction. Did the right person sign this transaction? So if I submitted a Hedera transaction that modifies my state, so far as I signed it, I have given my approval. And so the network was good. This might mean that I have, it essentially assumes knowledge that I have looked at this transaction and said, I'm okay with anything that happens within the whole line of transaction implementations or executions, right? And so this is another place where we kind of saw that the EVM looks at the addresses, maps them over, and that's where permissions are sorted out, whereas Hedera looks at the keys and who signed it and if it was right. And so we had to think of a new security model that worked for both of them. And so that's this new one here, where essentially what we said is, with smart contract executions, we start at the base. Whatever the EVM says is, we will acknowledge it. And so an address or an account can only modify its own account. So we acknowledge that. The next stage would be the modifications that have been made by the ERCs. So let's take ERC 20 or 721, where you have things like approvals. So I can give any one of you an approval to spend some of my balance and transfer it out. We'll acknowledge that. And then the last part would be, Hedera-specific advanced functionality, where, again, keys somewhat come into play, where I might say, for my account, I will not receive any HBAR until I sign off on it. Or for a specific token that's being transferred, unless I've associated with it before and given approval, that thing's not going to go through. So now with every smart contract execution, we are able to be EVM equivalent by honoring the security model, but also still exposing our advanced functionality on security as well. Now moving over to the node features, we had a lot of decisions to make, right? I'll try and dig into some of these, but I won't be able to do them justice. We had a layer choice. So this is around 2021, 2022. There's lots of discussions about L1s, L2s, and even, I think for a brief time, L3s, if that's still going on. And we had to answer, what do we want to be? Do we want to just make it so that L2s can go off and just settle on Hedera? or do we want to have like a first-class citizen experience on there? And we ultimately decided that the right thing to do as a ledger, as a blockchain, would be to have an L1 experience. And so that meant that natively, pointing to Hedera, you should have the experiences that you expect. So we had to look at things like our EVM client support. So you would have heard Lehman and others talking about the fact that we did have smart contract support coming out of the gate, right? But it was a different kind of smart contract executions. We used the Hedera API logic, and so you had to call Hedera specifications and provide it in that way. We used the Ethereum J client, but what happened over time is it no longer was supported. The contributors there weren't, they moved on to different things. They did a great thing, and as open source goes along, it doesn't always continue, right, unless there's sponsorship. And so we had some really great minds that came together, Richard Baird, Jasper Potts, I want to call out Dan O'Farren and Daniel Ivanov from LimeChain and a couple of others, right, came together and like, what does this thing really look like? And we were able to identify that the Hyperledger Besu client, another Java-based client, was doing the right thing, right? They were pushing for it. They were pushing for advancements. And so the right thing for us to do would be move to the Ethereum J over to Besu. And that gave us a lot of compatibility, and it helped us along our journey, right? It meant that whenever changes to the EVM model were made, so far as Besu did it, we were able to get it by integrating. Another thing that we had to look at was the EVM transaction API support. The Ethereum JSON-RPC specification, or at least the EVM, if you read the yellow paper, talks about RLP encoding, right? That's very different to what we do on the protobuf side. So we had to look at, which API do we want to cover? Do we need to reinvent the wheel? Do we need to support it sometimes but other times not? And a really ingenious but simple solution came up is, why don't we just support it as it is? If our real problem is submitting to the network because the Hedera API is different from the EVM API, why don't we just wrap the RLP encoded transaction, right? And so really this is what we do. We just, we take an Ethereum transaction that is fully formatted in the right way. We just give it as an entry as a property on a Hedera transaction. And so it's able to be received by every consensus node. And at the time of execution, we just unwrap it. We take that RLP preserved encoding and we give it to the EVM, and everything works as normal. We also looked at transaction ID support. And so on this end, we had one of these challenges where on the EVM side, a transaction is identified by its hash. It's not very human readable, but it does the job. On Hedera, we had this idea of a human readable transaction ID that kind of gives you information about who submitted it and an approximation of a time when it was valid. But again, this was another place where it wasn't necessarily working. And so the solution that we came up with was linking them. So allowing people to search by their hash and then linking that internally to the transaction ID that we would, and then finding it and then giving them that information. We also had to look at the key type support, and so ECDSA-based accounts, like I said, were the ones that the EVM supports, but Hedera came out the gate with ED25519 support. We also do things like threshold keys, where you could say that 2 or 3 people have to sign out of 5, whatever it works for you. Also, we have key lists, right, where we say N number of people all have to sign the transaction. And so we added ECDSA support as well to be able to be EVM equivalent. Richard spoke about blocks before, and so we've always had this concept of blocks internally, but as part of this equivalence journey, we had to expose that. We looked at archive node support as well, and so we mentioned the mirror node support before. One of the interesting things that the EVM gives you is there are 2 calls, the estimate gas and the ETH call, right? These aren't state changing transactions. They're more so simulations of, hey, what would it look like? How much would it cost? What would happen if I ran this transaction? And so being able to support these free queries out the gate was also something that we needed to sort out with. And then also on transaction data traceability. Up until this point, we allowed you to execute smart contracts, but you couldn't really dig into the details of it. Like, where were the logs? Like, what state actually changed? And what was the bytecode versus the init bytecode? All of these things. And so we had to expose that. I want to call out account interoperability, because this one was an interesting place where we started off with, like I mentioned, EDD type keys, and We have this account ID format. Again, the goal from the originators was, let's provide human-readable, easy-to-talk-about account. You ask me what my account is, and I can just tell you it's 0.0.1001. So my account number is 1001, it's on a shard 0, and it's on a realm 0. That's much easier than giving you like a 20-byte address that you can't really remember. But again, for good reasons. But when you compare that to the EVM, what you were able to do on the EVM is that you can take an ECDSA private key, you can calculate your public key, this is all math, you can take a KEKAC 256 hash, and then if you take the last 20 bytes of that and add the prefix of 0x, that is your EVM address. Every time you go to MetaMask or anything else, that is the address. That's how you link your private key to your address. But these things don't interact. So when somebody would say, hey, I want to send you value, and I say, oh no, send it to 0.0.1001, they're like, what does that mean? Or if you tell a Hedera developer, it's like, okay, send it to this address, EVM address, again, it didn't click. So we had to look at our account entity and properties, and we had to modify it. So what we did was another ingenious but simple thing. We added a field called an alias that would hold the EVM address, but we also had to look at our creation models, right? So on the EVM, accounts really aren't created. Because they're just addresses, you never really need to worry about does it exist or not. It's just does it have a balance? On Hedera, because we offer a lot more properties and other things, we actually create accounts. So we updated our creation model to have 2 new entries. So we can do a crypto transfer to an address. If the account doesn't exist on Hedera, it automatically gets created in the background. That shard realm num gets auto-created, and you can come and fill in your key later, but the alias has your EVM address, and you are identifiable. You exist on the network, right? But also, if you go the regular approach of doing a crypto create, you can specify the EVM address at the entry or at the beginning of that. I also want to talk about node token support. So as I mentioned before at the beginning, Hedera has native tokens, right? We put a lot of work into working with the IWA Foundation and looking at how should tokens be formed, right? What does fungibility mean? When you transfer, and what does that look like? And so Hedera has that support. But the EVM approaches tokens in a different way, right? They're really contract data, right? So an ERC token or ERC20 or 721 is really just information within inside a smart contract. And so how do these two things interact? Fortunately, like I said, because we did that study and we were very intentional about how native tokens worked, we found out that we could add this logic of a proxy redirect where we could treat native tokens as if they were ERC20 or 721 contracts. And so if you had a native token, you could treat it the same way you would treat an ERC20. If you had a non-fungible token, you could treat it as a 721. And so to a smart contract, it doesn't care, is this a contract or is this a native token? Everything works the same. You can ask for the name, the symbol, you can do a transfer, you can do an approve. Then one of the interesting things we found out is that for a contract specifically, if you take the ERC20 and 721 methodologies, but then you add this logic of native token services and the smart contract service, you get a really interesting hybrid DeFi environment where you can do a lot of things that you couldn't do when you were thinking about the EVM only, but you can if you want to. Basically, we put a lot of choice into the developer's hands, and you can come up with a lot of really interesting scenarios. Saucer Swap was a really interesting example of this, where they decided to sort of mix and match as made sense for them and their customers here. We also looked at bridging the EVM experience. It's great if the network and the nodes support the functionality, but if the tools don't, it doesn't really help anybody, right? And so we had mentioned before the JSON-RPC relay at this time, 2021, end of that, didn't exist. And so there was no way to really point EVM tools over. And so we added this abstraction layer on top of the Hedera consensus and mirror nodes. And so when you point to a relay, like as you would with any other network, you've probably pointed to Infura before or Alchemy, you can now point to the JSON-RPC relay on Hedera, and it does all the translation for you. So you can call ETH send raw transaction. It takes that transaction, it wraps it like we said before, and it submits it to a consensus node. You can do an ETH estimate gas or an ETH call, same thing. It figures it out, and it says that this should go to a mirror node, and I can make these REST queries in that back end, and then feed that information for you. But we really wanted to make sure that this flow worked, that any Web3 app could create its transaction as normal, sign it with any wallet. We decided to use MetaMask for an example here, but it could be any wallet. Submit it to the relay, just like you would on any other EVM chain, and it just works, right? We also looked at, again, exposing more of this information. And so up until now, again, this is about 2022, contracts could be deployed, but users like ourselves couldn't really see what it was doing, right? Unless the developer decided to share it with you. Now, this is very different from other EVM chains where you could go to the Explorer and see a verified contract. So again, in the spirit of open source, we decided to not go and rebuild the wheel. We wanted to look at what great people had already done. And so we were able to find out, the Sourcify team had done this. We contacted them. We looked at their code. We tried to contribute some ideas and specifications that would help out with more chains than just Ethereum. And then we were able to integrate that. And so now, if you go to our Explorer, a developer can verify their contract. You can now see the human-readable, like Solidity information there. But also, if you didn't have a contract that was verified, we at least wanted to provide you with the opcodes, right? You should be able to see that the smart contract that you're calling doesn't have, let's say, self-destruct, if that's something that you're scared of, for good reasons, or some other opcodes. At least a developer or a security team can look at these things and see what this contract is doing. We had to also expose logs, state changes, and internal EVM transactions. Again, these are already available on the node if you call them, but we need to give you that graphical experience that you're used to on other chains. It's important for developers and users to come along and just see this stuff. Hey, I submitted a transfer. I want to be able to see that it went to the contract with more detail. And so we were able to add this to the Mirror Node Explorer as well. And this is kind of like the final image that kept allowing us to see where we were on our EVM equivalence journey, right? On other chains, you can take a wallet, go to an anonymous faucet and get your native currency, use any EVM tool of your choice, deploy your contract, index it as you like, and go to an Explorer. So we kept looking at this flow, and every time we kept finding out that, in that top big box over there where the EVM tools are, or the experiences over here with the Explorer, there are more and more tools, right? It then became interesting that you understood why the EVM equivalence endpoint kept moving forward, right? Because it's not just equivalence at the node and what the node can do, but it's the experience of developers and users. If a tool like Hardhat or VM or Foundry does not work on your network, are you truly equivalent if your users can't use it? And so we kept getting more integration projects where we found out that we really need to focus on this tool. And so I've called out a few, Web3, JS, VM, Foundry, the Graph as well. But I want to say at least in 2023, there are at least 22 different products that we had to really dig deep into the integrations and see where they're at. And mind you, not everybody does it the same. Some of these tools are on Cancun, some of these are on London, all right? And then, others are on, the former ones or, the latest ones. And so we had to provide that support because it didn't matter to our developer what happened. It's just about whether it works or not. They don't really care all the details. They just want to be able to deploy their contract and have their users use it. And so this is where sort of EVM equivalence begins to expand, and experience is really important. And so let me just wrap up there. So post considerations, looking back, 2022, we challenged the status quo. There was questions around, could this be done at all? And I mentioned some of the great minds that came in and said, this should be possible, right? We should be able to integrate with Besu. We should be able to add a JSON-RPC relay, and we got to work. In 2023, we committed to this idea. We began to re-strategize. We began to focus on that experience and make that play a forefront in our trajectory, right? And in 2024, we began to see like the fruits of our labor in a sense, right? We were in full swing. We had projects like Pith and Super Oracles. We were able to bring in Chainlink and Layer 0 and the Graph and much more. And in 2025, right now, we're taking it to the next level, right? We have some hips around dynamic token metadata support that we want to bring to smart contracts as well. I mentioned the 15 million gas per second throttle. Again, that's us, I said, throttle down, right? That's just a number that we use for compatibility reasons, but that's not our limitation. And so we believe that this year we'll be able to increase that number and take it further. So you will be able to have faster and more applicable gas for your usage, right? The Pectra hard fork is pending and about to come out soon. We will support that this year too. And we want to look at hyperspeed EVM transactions as well. You shouldn't be sort of defined or held down by the EVM. We can make it faster. We can capitalize on some of the advancements that we've done on the Hedera side. We also want to expose more native services. We had mentioned the Hedera token service. We have the Hedera consensus service. We have others like the schedule service as well. That's something that other EVM chains can't do. The idea of being able to schedule a smart contract execution or any other native one, we want to bring that to EVM developers as well. We want more oracles. We want more bridges. We have MetaMask Snap integrations as well, where we were able to put the Hedera SDK into a MetaMask Snap and expose all the Hedera APIs on there. And then also Ed mentioned this earlier, but we were able to also expose signature verification, right? That's whether it's the raw ECDSA or EDD2509 or the protobuf itself. Smart contracts should be able to do all of that and more. And so just wrapping up, our goal was to provide the best EVM experience, right, for you. Doesn't matter what your scenario is. It doesn't matter whether we felt we could make a better choice or not, but we wanted it to work for you. We wanted it to be simple. We wanted it to make sense. And whilst you're doing that, we hope we were able to expose you to the mind-blowing capabilities of Hedera, right? Those things that you can't do in the EVM, but you can do better natively. So learn more at docs.hedera.com. You can also look at our HIPs and contribute to them. It's currently at hips.hedera.com, but as Richard mentioned, we will also be moving over to Hyro. And I must say that we are hiring. This isn't a single effort person. There's lots of amazing minds, and we want more. And so please check out hashgraph.com and careers. Thank you very much.